Here we go. Welcome to our public information session about the Charles River Dam. We are really happy to have you all here. I'm Ona Ferguson with my colleague Maggie Ostus. We are going to be facilitating and helping manage the tech and logistics piece of tonight's meeting. And I'm going to go to Bob Rooney to give a welcome in a moment, but so that you know what to expect this evening, the agenda is very simple. If I can get my slide to advance. Come on. There we go. We're going to do our welcome and tell you kind of what we're doing tonight, and then we're going to jump into presentations by Bill McDowell, who's the town engineer. He's going to give a context and history and sort of why we're even talking about this big picture perspective. And then he will present the two options that are facing the town, the repair and maintenance option to rehabilitate the earthen dam, and the river restoration option to remove the concrete spillway and restore the river. We will wrap up and clarify next steps and adjourn by 8 p.m. But we're really thinking about this as the first of a several part session. The next couple are next week, and we'll tell you more about that shortly. With that, let's go, Rob, let's go to you.
Great. Well, thank you, Ona, and thanks for all the hard work to get to this point, which is really the kickoff. You could go to the next slide if you could. You know, it's been some time since the DEP has inspected our dams and our dam here, and as they do across the state. And it's like anything, like any kind of infrastructure, it's gradually aging and deteriorating and is now considered out of compliance with state regulations. So, you know, in the near future, we do need to make a decision about how we want to move forward. And I think we have enough time to explore different alternatives, and you'll hear some tonight, to try to envision what the future of this iconic landmark really in South Natick, what it'll look like for the next 100 years. It has a history, as many of you already know, that spans several hundred years, and really was how you know, areas were developed heading westward, because I-90 wasn't in place yet. So they used the rivers, and they used it for a lot of different purposes. So the question is, going forward, what exactly does the town and residents expect and want out of this river, and what needs can it serve as we make decisions about you know, to make it safe, number one, but how do we incorporate some of the views and the ideas that you all have, and we'd love to hear them in the next tonight and the next couple sessions. Gives us time to sleep on it and dream about it and see what is possible here, because you don't get this opportunity very often. And so in some ways it's a negative thing that you know, it has to be addressed, but in another way it's an opportunity to look at the years ahead and how we want to use this bend in the river. The next slide, please. You'll hear a couple different options from our town engineer. Bill will go through those in detail, and quite a bit of work has been done already. And so just to gather data so that we can have an educated conversation with you all, and be able to look at different alternatives. And it's really key that you know, we get input from the community, you know, on any of these large decisions. And so the way I've decided to do this is through as an advisory committee, who has then reached out to the community, and there'll be a back and forth dialogue for several months until we kind of narrow down the details about the path ahead. So ultimately, the plan would be to present a concept plan forward to the select board in the fall, and then obviously there'll be funding attached to that, which would probably then be voted on in town meeting in the spring. So that's the big picture, and certainly there's leeway and ability to flex, a week here, a week there, depending on the needs and what we hear from you all. We may need more time to do more homework. So so let's hear it tonight. Anything that that you'd like to get out there for the record, and most importantly, we'll talk about the sessions that are strictly for public input in coming weeks. So there's the website. You'll see quite a bit on that, with even the history of the dam, and as well as sort of the path forward. So stay tuned, and I appreciate everybody's time tonight. It's a beautiful night, and given my druthers, I'd rather be on the bank of the Charles River hosting this, but this is a much more efficient way of doing it. So I appreciate your forbearance on that, and looking forward to hearing from you. Next slide.
Thank
please.
you very much. All right. So what is this process in a little bit more detail to add to what you just heard? The advisory committee was convened a month and a half ago at this point, and they are about 20 of your friends and neighbors. I think 6 town staff and community members, many of whom represent commissions and various boards, and others of whom represent neighbors and tribal interests and other particular perspectives. They met once really so we could lay out this whole process, and so we could tell them we're doing broad public listening and information gathering as the first phase, and then we're coming back to them. So we are at this May 17th blue bubble, sort of in this upper middle. This is the information sharing webinar where we want to tell you what we know. And next week, we are having community listening sessions, which are basically part 2 of this. There are 2 in the hopes that for those who want to attend one of these sessions, one of the times will fit your schedule. May 25th is from 6 to 8 p.m., May 26th from noon to 2 p.m. And we'll be gathering a lot of your input and perspectives. We're also, during this phase and into June, putting out a survey, an online way for you to give all your input. So that will go live this week, so you can start to tell us your thoughts and feelings on all of this. We will be collecting all that input from the sessions and from the survey, and organizing them and posting all of that online for anyone to look at, and especially for the advisory committee to absorb before they start meeting. They will start meeting in the summer, and we'll meet regularly into the fall, and they'll be going into much more depth on all the different topics that come up tonight, and you're all welcome to attend those meetings and communicate with the committee and make your thoughts known. And then we're hoping that by the end of the fall, they have a recommendation to make to the select board. Next slide, please. We're putting everything on the One Project web page, that survey that will go live in the next few days, the results of all of this. So keep coming back to that. You can also go there and get signed up for notifications related to the project. We're trying to make this as simple and accessible as we can. And I think let's go to the purpose, and then I'll give a little bit more on how Maggie and I got to be in front of you. Somebody's pointing out I didn't do a very thorough job of that, so we'll do that. So today we wanted to share the process. We want to share what's known right now about the two choices, and then again, give you the context of how you can give your input. Maggie and I are facilitating the advisory committee. We work for a place called the Consensus Building Institute, which is based in Cambridge, and we work on public policy and natural resource related projects and help groups work together. We're neutral on the outcome. Our job is to help the process work as well as it can and let the committee do its work. And we're really so happy to be here. I should say we've been gearing up for this with a planning team for months now. We're like really excited to share what we have. Again, this is the beginning of this process. We know that the people who are going to watch this webinar have a real range of knowledge and perspectives and expertise. So we're trying to hit the right mark of all the kind of key information that we have at this point and learn from you what else you want to know. We'll try to answer questions that we can answer, and then others will inform the future conversations with the advisory committee when we go into more depth. So thank you for being here. We're going to shift into the presentation now, which Bill McDowell will do. And I see some questions coming in on in the Q&A, many of which he is about to answer, I think. So as you have questions, feel free to type them into that Q&A. We will do our best to get to a bunch of them. Bill will present in two pieces. First, he'll present the dam history and context, and then we'll pause and do clarifying questions. And then he will present these two options and impacts and what we know about that right now. Bill, I think we're ready to go to you.
Okay. Maggie, that doesn't seem to be responding to me. So would you mind doing the next slide, please? So again, I'd just like to reiterate what Ona said. Thank you for attending. We wanted to get this information out in as complete and concise a manner as possible with as many people attending as possible. So again, thank you for attending, and we will try to be very mindful of your time. Charles River Dam, how we got here at this point. I'm going to give just a little bit of historic context to begin with. Next slide, please, Maggie. So what you see here is a map that was provided by the Natick Historical Society. And this was actually included in a story map project prepared by Charlotte Diamont, who was a Wellesley College senior, as part of a history class final project. The story map is available on the DPW's Charles River webpage. The link to the actual story map is embedded in the text of the page. There have been several iterations of dams in this portion of the Charles River since the early 18th century, since the 1720s. Next slide, please, Maggie. This map, you see the original dams were in this area here. You see the blue circle that is the dam that is noted on this older map. There was also a crossing area, the cart bridge, what they call the Indian Stones, just slightly upstream of the dam. But there were several iterations of dams, plural, in this area, and they were used to raise the elevation of the river water to provide a more constant flow and an engineered elevation drop to be used for water power. The reason this area of the river was chosen was based on the shape of the river bottom in this area, the slope of the river bottom. Water wheels in this area powered several iterations of grist mills and sawmills, and also at one point the looms for the Bigelow mills. The next slide, please, Maggie. What you're looking at here is another picture from the Natick Historical Society, which is a great picture. This is actually a picture from the grand opening of the dam in 1934. The dam was rebuilt in 1934 as a replacement for a failed dam that collapsed in 1932. It was an old wooden structure. The dam was actually replaced based on, for three reasons, was beautification of the newly acquired parkland to the north and south of the area of the spillway. That area used to belong to the mill itself, which is at 22 Pleasant Street. That area was sold to the town for parkland on the north and sides of the river. They felt building a dam in this area, creating the spillway and the waterfall would beautify this area. It also held back an area that was basically impounded water that could be used for a swimming hole. And it could also be used for recreational boating and canoeing, which was very popular in this area at the time. The third reason this was also considered and the reason it was approved by the town to build was to provide employment during the Depression for local workers in this area. And there were quite a few local workers who worked on this dam while this was being built. Again, it was completed in 1934. Something to note as you look across the river, this is you standing on the north side of the river, looking across toward the entrainment area, toward the dam itself. You may see that there are some mature trees on that dam already. From its inception, there have been trees on this dam. Next slide, please. But just to note that 4 years after the dam was completed in 1938, heavy prolonged rains in Natick produced an extensive property damage, and it actually cost one person their life in downstream flooding from the dam. I just wanted to include this because I wanted to make clear that the dam was not designed and it has never functioned as a flood control structure. The dam was solely to raise the water level, to get the water level to a point where it would run down a raceway channel and power a mill wheel. Next slide, please. The dam currently is known as a run of the river dam. That means the water that flows through the river, the entire water volume that flows through the river, flows over that spillway. This is a drone picture looking west. As I'm looking upstream, up the Charles River, I can see Pleasant Street in the foreground, and I see the spillway with the water riffling on the bottom of it, a little bit more in the background. All of the water, as the water travels from west to east, all of the water in the river travels over that spillway. The elevation of the water is artificially raised by that spillway, but there's no containment. There's no actual flood control to this water. That water in equals water out. And that's going to be very important as we talk about this river and talk about the dam itself. Next slide, please. So what you're seeing here is an existing conditions plan of the dam itself. As you look at this, to the left side of your screen, you see a white area surrounded by blue. I've highlighted the water verge by coloring it in with blue so you could actually see the limit of the earthen dam itself and where the water extents are. The earthen dam is on the southern side of the river. This is the actual dam. This is the portion of this structure which is holding back the water. This is the structure of the dam. The spillway is a spout. The spillway allows the river to flow over the spillway in a controlled manner. That is the concrete portion of the dam, the man-made portion of the dam, and it is what controls the water flowing over the top of that spillway. In this particular view, Pleasant Street is in the bottom of the map, similar to the orientation we saw when we were looking at the aerial photo. You can see Pleasant Street extending from the south to the north along the bottom of the plan. If I stand on Pleasant Street and I look up the spillway, I am looking upstream of the river. The water flows from upstream to downstream, flows over the spillway, down to the downstream, the lower portion of the river, under the bridge, and through. We'll be using these terms throughout this. So we just want you to be able to see this. And we'll just throw an aerial photo over the top of this so you can get context of this. This is what the area looks like as an aerial photo. You can see the earthen dam. You can see the heavy tree coverage on that earthen dam. You can see the spillway itself. You can see the concrete structure through the water. You can see the riffle of the water as it comes down to the bottom of the spillway, runs around the island, and then runs underneath Pleasant Street under the bridge. So this is the topography of the dam as we see it. And these are the terms we'll be using: upstream, downstream, earthen dam, and spillway. And just by means of orientation, looking at this plan, north is to the right, the earthen to the south side of the river, upstream is in the westerly direction, downstream is in the easterly direction. Next slide, please. So the dam itself, it holds back, it impounds approximately 160 million gallons of water in the impoundment area. Again, this is artificially retained by the height of the spillway itself. This allows water to back up, travel down the raceway, and provided the power as the water fell from that elevation to power a wheel that would power a grist mill, it would power a sawmill, or it would power the looms. There's a certain amount of head loss, a certain amount of drop over the water that has to occur. That's why the spillway was built to the elevation that it was built. So based on the amount of water, the mass of water and height of water behind the dam, the State Department of Conservation and Recreation Office of Dam Safety has a classification for this dam. This is considered a high hazard dam. The classification is based on the potential for damage to life or to property in the area downstream of any dam in the event of failure of that dam. So the high hazard classification by DCR ODS does not have any relation to the operational status of the dam or to the physical condition of the dam, only to the potential for the dam to cause damage based on the mass of water held behind the dam. So next slide, please, Meg. That high hazard classification requires the owner of the dam, the town of Natick, to inspect the dam every 2 years. We report our findings of that inspection to DCR ODS, the Office of Dam Safety, every 2 years. So several consecutive reports to ODS on the Charles River Dam have rated its condition as fair and have noted the presence of the mature tree growth on the earth dam and recommended the removal of the mature tree growth and the woody shrub undergrowth on the dam structure itself. Tree roots compromise the structural strength of the soil that is the earthen dam itself. As those tree roots move down into the soil, they allow an area for water to get in and get behind that soil and loosen that soil. Were water to run over the top of that, that looseness would actually help erode soil and portions of the dam could erode away. This is why, Office of Dam Safety requires that dams themselves, earthen dams, have no trees growing on them at all. Next slide, please. So we have been told on a number of occasions that the dam is compromised and it's not in compliance with DCR ODS regulations. So in order to comply with the state regulations regarding safe operation of the dam, the mature trees must be removed and the dam maintained as an earthen structure, as a facility, not as just a pile of earth. Or the town could also choose to restore the river by removing the spillway, negating the need for a dam, eliminating its classification as a dam at all. The earthen berm would no longer function as a dam, and the regulations from DCR ODS do not apply. It is no longer a dam, it is riverbank. So we want to present these two alternatives to you as part of this presentation.
Thank you both. Clarifying questions at this point. This is just sort of where we are right now, and we're about to go into these two alternatives. Some of the questions we've seen come in are going to get answered in the presentation. Let's see if any of them. There's a question about the earthen dam and whether it's reinforced or has some kind of foundation of masonry or rock. You want to take that, Bill?
The original design of the dam showed that there was what would be considered to be an impervious core, which would be a silt or a clay material, which would not allow water to seep through. That was presented on the design plans. We have not done borings on the dam to discover whether that core was there, but there is no structure, no stone or masonry structure as associated with this dam. It is essentially a trapezoid of earth compacted and extended out into the river, and the mass of the earth is greater than the mass of the water pushing against it, and it holds it out. So no, there's no specific structure to the dam. It is an earthen firm structure.
There are some questions about the trees and kind of the determination that it might fail. Want to look through those, Bill, and see if
I'm sorry, I don't have the questions up.
Let's see. Oh, you don't have them up. Okay, let me pull these up. A question about whether somebody was in charge of keeping the trees from growing on the dam. And another about whether it's tree species or if the sort of threat to the stability would be the case regardless of tree species.
So the short answer to that question is the tree root itself, the tree root structure. So the type of species of tree would not make a difference. In this particular case, much of what is growing on the dam, we'll see this in the pictures, are white pines and hemlocks, which are somewhat notorious in being fairly soft-wooded and brittle and can just break in the wind. That is one concern. They present an area of, with a lot of needles that don't lose their needles during the wintertime, that catches snow during nor'easters. They're very susceptible to being blown over in high winds because of the additional weight of the wet snow on the pine tree itself. So in this particular case, these trees are a little bit more of a double risk than a deciduous tree, but no, DCR does not differentiate between tree species as to whether or not a tree can or cannot be on the berm. There can't be trees on the berm.
Thank you. I think a lot of these other questions are going to get answered when you present the options.
Sure.
Maggie, are you looking at them also? Do you see any other we should grab right now?
Did we want to talk about a question about tree roots preventing erosion and kind of that force? So in lieu of the tree roots, what would hold the earthen dam together?
Fundamentally, the earthen dam is held together by the earthen dam. It is the compacted structure and the mass of the and shape of the slopes of the up and downstream embankments that give it its strength. It is a massively wide structure. And the way it slopes and the way the water is pushing against it is structured in such a way that basically most of the force is down as opposed to lateral force on the dam. There is no specific magic to this. It's really just the trapezoidal shape of the berm itself. To protect erosion, we'll go into that when we go into the maintenance and repair option of the dam. We can talk about what we will do to prevent the upstream and downstream erosion over a long period of time. When we mentioned that there's been some erosive forces, that dam has been in place for 90 years now. So I have to expect a certain amount of decay over time. Even wind erosion over the top of the dam actually changes its elevation a small amount. However, 90 years of the river flowing up against the upstream side of it have caused a little bit of erosion. So once that area is regraded and reshaped, there would be installation of riprap in that area to prevent that sort of erosion from happening again in the near term. Over the long period of time, over 100 years, 120 years, there will probably be a small amount of erosion again.
Thank you. Let's take, I think, one more here. A lot of thoughtful questions. Thank you all. One more for the moment, Bill, is can you one more time just explain that high hazard dam? Like that
Sure.
could be interpreted a few different ways.
Sure.
Thank you.
There are two classifications that DCR takes a look at, either the height of the crest of the spillway, how high that is above the downstream face. If it's a very high spillway and the water's falling a large distance down, that elevation adds energy to the water were it to fail. That height of water falling down adds energy to it. Or they classify it by the mass of water, the amount of water. In this particular case, greater than, I believe it was 50 acre feet is considered a high hazard dam. There is approximately 500 acre feet of water, 160 million gallons being held by that dam in that impoundment area. That mass of water, that potential energy, should that water break through the dam, all of that mass of water would travel, in a direction that's hard to move or stop. So that inertia of that water as potential energy is what classifies the dam as a high hazard dam, just by standing there. Again, it's got nothing to do with its operational status, it's got nothing to do with how it's made. It's literally just the mass of water or the height of the spillway. That is what gives that water the potential, if it were let out immediately or let out catastrophically, that energy is what represents the danger to the downstream properties or the other possibility of loss of life. So That's what classifies the dam as a high hazard dam, is the capacity of that impoundment area and or the height of the spillway. Our spillway is not high. That's not how we qualify as a high hazard dam. We have a lot of water behind that earthen dam. That's what classifies it as a high hazard dam. That's what makes us have to inspect it every 2 years as opposed to every 5 years, which would be a low hazard dam.
Thank you. Let's get into these options. So Bill is going to present the 2 different options in sequence, and then he's going to talk about impacts of, and sort of compare some impacts of the different choices. Go ahead, Bill.
Thank you. So the first option we're going to talk about is the option that we actually started down the road of designing, because we got this information from our consultants that we were not in compliance with UCR regulations. We moved about getting the design work done to be responsible owners of the dam, and then we began permitting the process. So this is the repair and maintenance option. We are actually a little further along with this process than we are with the second option, which was the possibility of breaching the spillway. However, this we have design plans for. We still have done analysis regarding the breach analysis. We're just not as far along. Next slide, please. So here we are at the grand opening again. I love this picture. I just think it's great. About 3,000 people attended the grand opening. A plane flew over the top of it. Planes were really big back in 1934. They were all modern and everything else. This was considered to be an engineering marvel when it was created. Next slide, please. Just like you to compare that with what this looks like now. So if you wouldn't mind going back one, Maggie. If you're looking across, I'm seeing that stone area. I'm seeing the spillway. It all looks very nice. I'm seeing some of the trees, but I can see through those trees on the dam. I can look back through that. Next slide, please, Maggie. I can't see through that. So obviously the tree growth has gotten quite a bit more dense in the 90 ensuing years since 1934. There are currently 64 mature trees on the dam itself. And next slide, please, Maggie. This is, again, the existing conditions that you see. The brown dots that you see on the earthen dam to the left, those are the individual trees. There are 64 of them on the dam. That is too many on the dam. I can't have one, but all of these trees would have to come down. There are also some woody shrubs along the upstream face along the Charles River. You cannot walk down the berm and get to the water based on the shrubs that are there. Those woody shrubs also would have to be removed all the way down to the water line. So again, this is the existing conditions that you see here. You can see a little bit of that concavity as you look on the westerly side, the upstream side of the dam face. You can see that some of that soil material over time has been eroded away. Similarly, on the eastern side, where the water eddies back around in this wetland area on the downstream face of the side, you can also see a concavity. That's the water swirling in that area, eddying around and taking some of that soil material away. This is also part of what we would be repairing as part of the dam itself. The next slide, please. So the repair of the dam, this is actually a fairly typical procedure, and it's not extraordinary construction by any stretch of the imagination. This is done quite often. The first thing that the contractor would do would be to position erosion controls and cofferdams on the upstream and downstream side. I have a picture on the next slide to show you what a cofferdam looks like and how it works. We would dewater the area behind the cofferdam. That allows me to get all the way down to the base of the dam in the area that is currently inundated, the area that is under the water now. Once I had the cofferdams and erosion control set up, I would remove all the woody shrub undergrowth along the beach side of the upstream embankment. I would remove all of the mature tree growth on the embankment, on the dam itself. I would remove the stumps and then fill the stump voids with an engineered fill. I would bring in more material and regrade and compact the upstream and downstream embankments, the sloping areas as they slope down into the Charles River itself. I would armor the upstream slope, the side toward the water flowing towards it, with riprap. I'll have a picture of that on the next slide so I can show you what that looks like. And I would restore a more resilient grass on the downstream slope. Currently, because of all the evergreen trees on the dam, the entire dam is covered in a pine needle bed. There is no grass on this area at all. Once those pine needles were washed away, should that dam over top, all of that soil would be exposed. There is no grass that is holding that soil matrix together. So that would be a very dangerous situation were the dam to be over top. After that point, once the grass was established, I would remove the cofferdams and remove the erosion control. The duration of this portion of the job takes about 10 to 12 weeks. It's about a 3-month process. The total construction cost for this phase and a second phase that would be on the stone wall work next year is about $1.2 million. The next slide, please. So I mentioned that I had pictures of a cofferdam. If you look in the top left of this slide, that's a cofferdam. You see the area that is basically a blue plastic tarp. Behind that tarp are frames. They're steel frames that are set up in the river itself prior to rolling the tarp out over them. Those frames go all the way down to the bottom. They sit on the bottom of the river, and they're usually walked out about 3 to 4 feet off of the toe of the slope and then set down. Then I unroll the tarp. Once that tarp is unrolled, the pressure of the water holding the tarp down against the mud makes a fairly watertight seal. I pump the water out from behind the cofferdam. And if you look in there, you'll see a machine that's operating in that area behind the cofferdam. And if you take a look at where the water edge is along the blue tarp and look at where the level of the ground is behind that, I'm holding back about 3 or 4 feet of water in that place. I am allowed to work in that area without affecting the river because basically I've set myself apart from it. So again, this is the cofferdam. This would be set on the upstream and the downstream embankments at the toe of the slope so I could perform the additional work to grade that work behind the cofferdams. On the upper right corner, you see what's called riprap. This is a broken stone product. I use that to armor dirt and water interfaces. So basically, as the water laps up against the water, the velocity, the strength of the water, the erosive force is taken away by the hard edges of the rock, and quiescent water is up against the soil of the embankment itself. It armors the slope and it preserves the grading that I have behind that slope. If you look in the lower right, you'll see what an application of this looks like on a typical dam. Generally, it's the last 2 or 3 feet water that is the armored slope. It does not come up onto the crest of the dam. It's only there to protect the upstream embankment face. Next slide, please. This is a drone photo that we took of the Charles River Dam. You can see the extent of the evergreen trees on the dam itself. This was taken, I'm hovering above the impoundment area, approximately 20 to 30 feet above the water level. I'm looking down and over the dam structure itself. This is the earthen structure. I can see through the trees and I can see Pleasant Street in the background, running from south to north, parallel to the dam in this particular place. But you can really get an idea of the tree involvement on the dam. We used this photo and gave this to our geotechnical engineer, who had a landscape architect provide a rendering of what the dam would look like with the trees removed. Next slide, please. This is an architecture or a landscape architect's rendering of what the dam would look like with the trees removed. I'm still looking slightly over the dam crest itself. So this area that you see is actually the level top of the dam itself. The area right down by the verge is the riprap treatment, the riprap armoring of the downstream embankment. If you look all the way over to the left of the dam, you can see the area where the spillway begins, where the gate valves are, and the stone area is where you can go out and stand and look over the spillway. In the distance, you see the Pleasant Street Bridge. As I look at the dam, there's the area where the wetland starts to come back around behind the earthen dam itself. You can see that seam, follow that up, as I go to the south. That's the area where basically the dam starts to drop off again and goes down into the wetland area. The trees behind that you see are actually on the Pleasant Street embankment. Those would remain. They've got nothing to do with the dam. So there would be a certain amount of tree cover that would be left in that view looking towards Pleasant Street. Next slide, please, Maggie. So we put these two side by side so you could kind of compare them. That picture that you see on top, and you can see the brown that we were talking about, the pine needle top, that area would be replaced by a heavy dense grass. I noticed there was a question in the last thing, would there still be picnic benches and things like that on top of the dam crest? And the answer is yes, those are fine. You'd still use the area as a park. There would be a crushed stone path leading out to the gate valves by the spillway, So that area would still be a park. It would still be someplace where you could go. It just wouldn't be a shady spot anymore. It'd be a full-on sunspot. So again, this is what that area would look like. I know a lot of people were looking forward to seeing the renderings. This is a rendering of what the earthen dam would look like were all the trees to be removed. Can I get the next slide, Maggie? So repairing, maintaining the earthen dam, what that would result in, the concrete spillway or the waterfall and the geometry, the areas of the existing parklands on the north and south side of the river would remain as they are now. It would open the southern park area to sunlight. That whole area would have no trees on it. It would be a grassed area. It would remain as a grassed area, and we would maintain it as a grassed area. No shrubs, no trees. It would strengthen the earthen structure, the dam. It would strengthen that structure for decades. I don't know over time whether or not I would still have the erosive forces. It's, with the protection that we're putting down, it would be in better shape than it was in 1934. However, over time, I would expect it. I'm probably still going to get some small amount of erosion on the upstream face and probably some more on the downstream face. We are not armoring the downstream face, but there's no apparent need to. So it would strengthen the earthen structure now for decades. It would minimize the risk for catastrophic failure of the dam. It wouldn't eliminate it because it's still possible to get a storm that is in excess of what that dam is designed to hold back that would flow over the dam. It is possible over time, if we had something in excess of a 500-year storm, that it is possible that that could become, that we could have some sort of failure of the dam, catastrophic or partial. However, it would be extremely unlikely. So I do want to say it's going to minimize the risk for catastrophic failure of the dam. It does not eliminate it. It would still require the biennial inspections for the Department of Conservation and Recreation's Office of Dam Safety. We would still be required, because it's still holding back that same mass of water, would still be required to perform those inspections and report to DCR ODS every 2 years. This would also, like I said, it would likely require some grading or repair work 80 to 90 years in the future, similar to what we're doing now following the construction of this back in 1934. Next slide, please, Maggie. That was the maintenance option. So now the second option that we're going to take a look at is spillway removal, or what we're calling river restoration. That is what the DEP would also call this as well, restoring the natural flow of the river. Next slide, please. So if the river restoration option is chosen, there will be changes to the spillway and to the land upstream of the dam. There will not be any changes to the dam itself, the earthen dam. There will not be any changes to the downstream area. We are removing the spillway. We are taking back the artificial elevation raise of that area that's keeping that additional water in the impoundment area. Just for reference, this is the area by the Bacon Free Library. These are the two millstones that you can come down and see and take a look at. And the area here, the railing that you can stand and look at the spillway. So you're basically looking towards the south. This is also a drone photo taken from probably about 60 feet up in the air, just to give you a little bit of context. The next slide, please. So the steps for removing the spillway and restoring the river, again, this is a fairly typical process and has been done many times in many other rivers, in many locations around the country. So the first thing that we would do, we would lower the existing river water level in the impoundment area using the gate valves that are part of the dam right now. That would take approximately 3 to 4 days to lower the river elevation to the point where the spillway and the spillway apron was dry. We would then redirect the flow of the river from the north to the south. We would guide the river to the south using sand barriers, which are fundamentally just big sandbags that are placed by machine. They're approximately 10 feet in diameter. And when you set them side by side, they form a nice watertight barrier. And I would guide water as it came around from the west. I would guide it toward the south, toward the valves themselves, and force the water to be that area so I could do work in the dry on the spillway itself. After I had the sandbags placed, I would establish inner erosion control to make sure that my construction debris, that the concrete rubble did not mingle with the water in any way. So I'd have an erosion control, I'd have a barrier between my construction site and the river itself. Following that, I would construct an access ramp for the machine to get in and out of the river itself, down onto the apron of the spillway, so it could begin breaking down the concrete in that area. The machine itself would go in and out every day. It would never remain in the water itself. It would be out of the water during, when work was not happening. It would only be in the water, or I'm sorry, in the area of the spillway while construction was actually taking place during the day. Using an attachment to the excavator called a hoe ram, I would break the existing concrete spillway and the footing, and I would remove all of that concrete material. Following that, I would remove the river barrier and the erosion controls. The duration of this job would be approximately 2.5 months, with initial construction costs of approximately $500,000. At this point, we don't have a design for this, but we definitely have an opinion of probable cost based on the work that would need to be done. There was a similar project that was done up at St. Regis Falls in upstate New York. And Maggie, if you just, next slide. So this is actually a very analogous structure to what we have at the Charles River Dam. If you look at the picture in the upper left, that orange line that you see is actually the line of a barrier that is redirecting the water toward the valve structure, which you see as a building. This was actually part of a hydroelectric plant. That's where the turbines were. But beside that building, just to the right of that building where you see the riffled water, that's actually a valve structure, and it allows the water to be lowered in this area. You can see the machine in the upper right picture, approximately halfway across the river. It's on dry land. That area used to be completely covered with water as the water flowed over the spillway. By lowering the water below the spillway elevation, it gives me that room to be able to operate that machine up against that, up against the spillway. Once that area has been, the spillway has been broken, they remove the barriers along the northerly side of the river, or in this particular case, the right side of the river, and then they build it around the valves itself, and they take out the last remaining bit of the valve structure. So in the lower right corner, you see the second portion of this where they're taking the remainder of the spillway out. And I want you to just take a look at the water as the water's being directed around where the dam used to be, where you could see him breaking the concrete. You can actually see the rocks underneath. The concrete comes up very cleanly off the rocks, and this river basin has been basically restored down to its rock bottom with no remaining concrete in that area. The next slide, please, Meg. So this is a drone photo that was taken in fall 2019, similar to the other photo, and we sent this picture to our consultants, to the geotechnical consultants who had their landscape architect perform a rendering of what this would look like were the spillway to be removed. And before I go to that picture, I'd just like you to take a look in this area as you come down from the library. You see the two millstones. Look at those areas as a reference, because that's the area the spillway extends from north to south across the river. And so when you look at the next picture, you'll see that there is no spillway there at all. Maggie? So you see the millstones again, and that area of the spillway, the water is flowing through that area. This river cross section is based on soundings that we did of the depth of the river, where that river would maintain depth as it flowed through this area, and where the area of the shallow portion of the river on either side of that, that's where that area would be exposed once I removed that spillway and took that artificial raising of the water and lowered it down. I'd be lowering the water between 5 and 6 feet on the upstream side of the spillway. You can see the accretion of the land here, especially on the northern side of the river. It's quite obvious, but you can also see it along on the southern side of the river. Maggie, would you just flip back real quick to the drone photo? So again, this area to the south side of the river and the north side of the river, you see them as water now, and flip. And now you see that this area here would be grown up. This area would be an area of soil. You can see the entrainment wall back here. This area would no longer be inundated. The river would be narrowed through this area considerably. And the side-by-side pictures. So again, you see the drone photo in the upper left. And if you look down, the photo rendering of the area performed by GZA of the river where the spillway to be removed on the lower right. So removing the concrete spillway, what that would do, that would eliminate the waterfall, the spillway and the water, cascading over the water or the waterfall itself would be removed. It would not exist anymore. It would retain the existing tree growth on the dam as it stands now. There will be no trees needing to be removed from the dam. It is no longer a dam. It is not classified as a retaining structure of water of any kind. So that classification would be gone. There'd be no need to remove the trees off of the dam. So eliminating the structure's classification of a dam would also eliminate the town's liability for potential damage attributed to dam failure now or in the future. It is no longer a dam. It is no longer a risk. It would eliminate the need for biennial inspections and reporting to DCR-ODS. It would eliminate the future maintenance of the dam. As we said, maybe 100 years from now, we'd be doing the same sort of work again. It's as a dam, if it's in the water and it's working as a dam, we would be required to maintain that in perpetuity or until somebody considered doing this at a future date. So what that would also do by taking away the spillway, it would restore the natural flow of the river. The river would not be artificially raised at that impoundment area anymore, and it would actually improve the migration capability of two different species of anadromous fish that use the Charles for their breeding grounds. Eliminating the spillway would lower the water level directly upstream of the spillway by approximately 5 to 6 feet. And again, you saw that area as the river shrank, the width of the river shrank. That's based on the volume of water that's traveling through that. That would be traveling through at a lower elevation and at a deeper portion of the channel. This would also, if we eliminated the spillway, it would eliminate the town's risk during extreme weather events, having to worry about, would the dam to fail based on tree falling or just basically being overtopped by rainfall that exceeded the dam's ability to pass the river water. Next slide, please. So those are the two options. And what we've done is we kind of put together a matrix so you can sort of see the impacts beside themselves. And this is, at a very, very base level as far as the impacts. We will go into this more. This was really just to kind of stimulate your thought processes for questions that you may have regarding these two options. So we wanted to have them kind of a side-by-side, an apples-to-apples sort of comparison of these for the several areas that we came up with. Next slide, please, Maggie. So the flooding impacts, as we noted before, it's a run-of-the-river dam. So the river flows normally and continuously over the spillway until there's periods of severe drought where the river actually may get to the point where it is not over the spillway anymore and actually evaporates to a little bit below that level. And that does occur during particular years. I mean, you'll see that, in August and September, it is possible for the spillway itself not to be running. This dam was not designed, does not operate as a flood control structure. It never did, it never has. So maintaining and repairing the earthen dam would not increase flood control or provide flood control. There is no flood control to this at all. Water into the impoundment area equals water out of the impoundment area. Once that spillway is full to the point where water is running over the top of it, it provides no flood control at all. So as we look at this, the flooding impacts, you look on the left side, the repair and maintaining the earthen dam is the area to the left. The area to the right in the blue is removing the spillway. So the downstream water levels would not change. I know that doesn't sound possible, that I would take out the dam and the water level would remain the same, but water in over the spillway is water out over the spillway. Once that equilibrium is maintained, once I've lowered that water by a controlled lowering through the valves, the river will run as the river has always run. The downstream levels will not be affected by removing the spillway. The upstream water levels would be unchanged if we repair and maintain the earthen dam, because that is still, if we hold that water, artificially elevated by the spillway, that will remain the same. That area of the impoundment will remain the same. Were I to remove the spillway, that will lower that upstream water level approximately 5 to 6 feet based on the size of the spillway in that area. So that area, the impoundment area itself, would appear shallower or appear lower as it goes because it's not traveling over the spillway at this particular point. So the inundation risk, the risk of flooding, remains unchanged in both of these situations. I am not changing the capacity of the river. I am not changing its ability to pass a flooding event or a heavy snowmelt event. If I get a heavy inundation, heavy water rainfall, the water level will rise and the water level will flow through the river, and the floodplain will remain the same upstream and downstream of the spillway itself. So for the risk of dam failure for flooding impacts, the risk is lowered by the maintenance option, but not eliminated. The risk of dam failure, because it's no longer a dam, the spillway is removed. There is no longer a risk of dam failure. It is not a dam. And the water will pass beyond the dam. It will not be raised to that elevation. It will not threaten to overtop the top of that dam because it will be passing at a lower elevation. Next slide, please, Megan. So ecological impacts. There are a lot of ecological impacts when considering the removal of a dam on an existing river system. So again, the Division of Ecological Resource estimates the removal of South Natick Dam would result in a high ecological value relative to other dam removal projects across the state, fundamentally because of the type of dam that this is. This is basically just a hurdle in the middle of the river. It doesn't provide power. It doesn't provide anything other than fundamentally a pretty waterfall. There's no power taken off of this in any way. We're not backing up water to go down a raceway. There's no real function for the dam. So basically what they're looking at is this is just an ecological impediment without any real benefit toward to the human environment. So looking at this, there are potential construction impacts by both of these options. In other words, I'm working down at and below the water level on both of these projects. I have to make sure that I maintain separation from my construction site and from the water itself. Were there to be a heavy rainfall event during construction, we would have to prepare for that for probably a couple of days in advance type of thing to make sure everything was buttoned down and make sure that the water would not travel through the construction site. So there's the potential for construction impacts on both of these projects based on the location where I'm actually working. For fish and native species, the fish migration for the maintenance of the dam would remain impaired. It would remain impeded because I still have that hurdle in the middle of the river. And I don't know if anybody's seen this, but you can actually go down and see the fish trying to get over the spillway during periods of time in the spring. They are still in the water and they are still trying to get up there. I can't seem to make them see the ladder tonight. They don't see that. If I was to remove the spillway, migration for those fish would be restored. There would be no impediment in that area. Native plants would also be reestablished based on the flow of the water through that area, the distribution of sediments through that area, and the regulation of the water temperature. When the water sits in the entrainment, in the impoundment area, it warms up. It's still water, it's in the sun, it warms up quite a bit. That creates the ability for algal blooms and for invasive species. And along that northern wall by the Bacon Street Library side of the park, there's always a lot of growth in that area, right by the pathway itself. The river flow, right now, that river flow is impeded by that artificial hurdle that it has to go over, the spillway. Were that to be removed, the natural river flow would be restored through that area. Sediments in the area. The sediment distribution right now is interrupted. Basically, as the water comes in and goes quiescent in the impoundment area, sediments settle out. So I have larger amounts of sediment above the dam, and the area is considered to be sediment starved below the dam. Those sediments are part of the breeding habitat for many fish and many other amphibians in the river system itself. So the more even distribution of sediments along the river is a benefit to the ecology of the animals that are living in there. Sun exposure for the maintaining side, if I maintain the earthen dam, I'm increasing that sun exposure on the southerly side of the impoundment area. Currently, there's a certain amount of shade that is shaded by those pine trees until I get to about 10 o'clock, 11 o'clock in the morning, and then the sun is full on the water. Without that, that sun would basically be on the water that entire time. Not a huge difference during the summertime. However, it would allow more solar heating of the impoundment area itself. There would be no change to the sun exposure or the spillway to be removed because the dam would not be touched and the trees would remain as they are. So trees and habitat on the earthen dam, obviously they would all be removed under the maintenance, the repair option, and the trees and habitat would remain on the dam right to remove the spillway. So again, the water temperature based on the area, the impoundment area, of slowing the water down, leaving it in an area of basically stagnant water, that water, the temperature is raised quite a bit during the day and quite a bit over the period of time of the summer where that water is just barely creeping over the spillway. That water that sits inside the impoundment area, it heats up considerably. The water temperature would be regulated because it wouldn't be standing still if the spillway was to be removed. Next slide. Financial impacts. This is probably one of the reasons why when this came up as a question that we are considering this based on just the practicality of owning a dam. There would be obviously large financial impacts were the dam to fail and were the town to be held liable for any of the downstream impacts that might occur, the damage, property damage, or potential loss of life. The town is actually in a fairly exposed position, having the dam such as it is. Right now, we have completed the design of the maintenance option. We are ready to, the engineering has already been performed. We still need to permit that through state and local permitting options. The cost for that work would be approximately $50,000. The cost for permitting the spillway option, this includes the engineering as well as the permits. We have not had the engineering performed at this time. So our estimate is approximately $180,000 with permitting and the engineering. The permitting is a little bit more involved with the spillway breach because we have more hurdles to go over, more state entities to receive permission from in order to remove the spillway. The construction costs have been estimated for the maintenance option at $1.2 million. The construction cost, that's a two-phase project. We were doing the dam work this year, or the year that we chose to do it. And then the second year, there's additional stone and masonry work that needs to be done on the entrainment walls, particularly along the north side of the river. But that is not work within the river itself. That is basically stonework. It wouldn't have the same implications of the work that we're doing now. This is considered to be the more expensive portion of this. But the total cost for phase one and phase two is $1.2 million for the maintenance option. For breaching the spillway, the estimate right now is approximately $500,000 for the work that needs to be done for the spillway. That's a one-shot deal. Take the spillway out, remove the rubble, and you're done. So the total of this, 1.25 million. And we have about $680,000 for the spillway option at this point, just to do that work and get that work permitted so that we could get that work done. The maintenance for the earthen dam is very, very small. I mean, we're just throwing $400 at it. It's basically just keeping the lawn mowed and making sure we don't grow any more woody shrubs on that area, making sure the trees don't grow up on that area. It's fundamentally just, mowing the lawn. So again, approximately $400 a year to do the work that would need to be done there. There would be no maintenance work that would be required for removing the spillway. The dam could remain as it is. It could remain treed. Inspections were required for the repair and the maintenance option. I am required every 2 years to perform the inspections for the Department of Conservation and Recreation Office of Dam Safety. Right now, those inspections have been costing us $5,000. They've cost us $5,000 for the last 4 iterations. I'm expecting that's going to go up either this year or within the next year to about $7,500 every 2 years. I would expect that price to go up, in relation to inflation over time. But every 2 years, we are required to report to ODS regarding the condition of that dam. We would not be required to perform any inspections were we to remove the spillway. So the cost for future regrading, we're throwing that out there. Right now, it's costing us $1.2 million to work on a 90-year-old structure. I would expect that somewhere in the neighborhood, 80 to 90 years from now, 100 years from now, some other project would be doing fundamentally the same work, beefing this up. It may be possible that based on what we have for weather changes, that they may end up having to raise the crest of that a little bit as well. However, I'm not anticipating that at this point. So the other thing for anticipated future work, there's the potential to convert the new land that we have on either side of the riverway, that it is contiguous with the parkland that we now have, that area could be converted into some form of passive recreation to be able to get down to the water's edge itself. So we don't have a number for that. We're not really getting into what could be done with that area because again, we haven't decided what we want to do with this, and we don't want to put that out there like that's some kind of prize at the end of this, so we could actually end up with more parkland. The liability, this is really the biggest portion of this. By just owning the dam, I have the potential for multiple millions of dollars for damages that would happen based on a dam failure. And when they happen, we own them. It is strict liability, we own the dam, we own the damage that it does. What we were looking at again is the idea of we have been told on multiple occasions that we are not in compliance with regulations. Were the dam to fail at this point, that's kind of an aggravating circumstance as well. And that could actually open the town up to even more liability for an aggravated circumstance of negligence, basically for not maintaining the dam. The liability and risk with the dam, if the dam is eliminated as a dam structure, is zero. There is no future risk whatsoever. It is not a dam. It is not regulated. It will not fail. Next slide, please. So this community use impacts, these are really what we're looking for from you, the audience. You know, what do you see as the community use impacts? This is really where we expect the nitty gritty for this to happen. Is like there is a reason, a rational reason why you may want to remove the spillway and remove the risk, but there are a lot of sentimental reasons as to why you may want to keep the dam, and because the dam is in an iconic spot and really just a lovely park area. So these are the community impacts. We're looking for your input on this, and we're really looking to see and get your opinions on what would be the community impacts as you see them for these two options. That's all I got.
Thank you, thank you. And we have 70 questions. So Bill, we're not gonna get to all of them, but Maggie and I have been going through them and trying to figure out which are sort of most overlapping, and we're just gonna start in and try to get through a bunch of them with you. Bill, can we ask you to just give kind of high level responses so we can move through some different topic areas? Is that okay?
Yeah, I will try. I'll try to give as complete an answer as I can in a relatively short period of time.
Thank you. First up, some current condition. Well, it's hard to group them. I'm just going to go question by question. Is the spillway in decent shape? Is there any concern with that part of the place?
No, that was actually inspected 2 iterations ago. They actually did some diving. There is some work that needs to be done around the gates. That box area on the southern side of the lake where you can stand and look over the spillway, that needs some concrete work. The spillway itself is in great shape.
Thank you. Are there implications for the Pleasant Street Bridge, either of having or removing the spillway?
We had asked that question regarding GZA. They're also geotechnical, so they're looking at the area of the interface between the footing of the bridge and where the river runs by that. There may be implications, based on the speed of the water traveling through there. They do not expect that is going to be an issue, but that is something they will be looking at. There may be some work that needs to be done near the footing of the bridge to armor that.
Thank you. What conditions would cause flooding, and has that ever happened to overtop the dam? I think you mentioned it, but if you could just say it one more time or a little bit more.
Yeah, there have been several instances where the river level has risen. It has not gotten beyond that park area. It has never topped over the crest of the dam itself. It has gotten close, but it has not crested over. The danger if you go over the crest is that as the water travels over the crest, it takes soil material with it. And that erosion feeds on itself and becomes a cascade. So that's the issue. The dam itself was designed to pass the 500-year storm, a storm so severe that its likelihood of happening is 0.2%. We have had storms not in excess of the 100-year storm since that time, and certainly not in excess of the 500-year storm, but we have had periods of time. In 2010, I know we had a period of time where we had a lot of rain, it stopped, and we got a lot of rain on top of a lot of rain, and a lot of areas flooded significantly. There was flooding in this area. It never overtopped the dam. And we don't anticipate, based on the hydrological models that we've created, even with increased rainfall in the area, we still do not anticipate that the 500-year storm would not be able to be passed over the spillway without cresting over the dam.
Thank you. There were several questions about the ecological benefits, which you then talked about. Can you name offhand the fish that are affected? And several people asked about the fact that if there are dams further downriver, it still helps with fish passage.
Yeah, the fish are named Fred and Ethel. They are shad, and there's another form of herring. And I did look it up, and I apologize, and I don't mean to be facetious. There are two species of fish. I can find them again. I just don't recall them off the top of my head. One is a shad, one is a herring.
Okay. Where would the sediment go if you remove the spillway? What happens?
So as part of this work, and we will get into this in a lot more detail during the question and answer, as part of this work, in order to determine if a breach was even feasible, to take the spillway out was even feasible, the first thing that we did was we performed sediment testing upstream and downstream of the spillway itself. They chose 4 locations upstream and 2 locations downstream, certain distances away from the spillway. And they were checking for depth and constituency of the sediment itself. What they're looking for is if there's anything, the difference between the two, upstream and downstream, if there's anything in the upstream that would preclude you from allowing that sediment to travel downstream. They did note that the 2 constituencies of the sediment upstream and downstream were very similar. And they also noted that it was what they considered to be remarkably clean. So there are materials in that sediment. However, they are not at the concentrations that would be problematic. So it was determined that the sediment itself would not be an impediment to the breach of the dam. What would happen to that? As I open up the gate valves themselves, I'm opening up 2 valves that are below the spillway. So when I do that, the water would start to drop. That water would go through the gate valves. Because that's smaller than the spillway, that would be running at a faster rate, and it would probably be taking some of that sediment with it. That sediment would flow down through the downstream area and fill in amongst the rocks and the gravel that were there. But we're not talking about letting go of metric tons of sediment at this point. We're talking about letting go of sediment, in the pounds type of neighborhood while that was going through the gate valve. Once that water was dropped below the gate valve elevation, then the rest of the sediment in that area would just remain down in the river bottom where it is now. So there would be some scour when I did the original lowering of the water level, but it would not be to the degree of tons of sediment or anything like that.
Thank you. How far up the river would there be a noticeable drop in water level? And should people be worried about sort of stagnant, muddy conditions, especially in the season when there's not such high river flow?
Okay, well, we mentioned that this particular part of the river was chosen based on the river bottom's ability to deliver water moving at a certain speed to keep the water moving. So if you think about, this is the bottom of the river and I'm stopping water here, from the top of my fingers to my water, that's the area that I'm impounding. That's similar to what's happening now in the Charles River. I have something like this. So this impoundment area would be the area that I would drop the water here. But the water up in this area, which is slightly further west than the footbridge over the Charles River, which is about a half a mile to the west, that area would be insensible. You would not see any change in the river width based on the bottom of the flow and the water flowing through that area. So that is part of what our geotechs did as part of their analysis, is looking at the river bottom, the profile of the river bottom, and then running the water through there, the water that's coming from rainfall and coming down. As I come into the watershed, it runs into the river. They can see, based on the size of the river, it's like the size of the pipe, how deep that water would be. So that was their estimation, that it would be less than the distance to that footbridge, that I would actually start to see the width of the river starting to narrow down. So that's what we have. They can give us basically the point, but that they did call that out because it's someplace that people are visually familiar with. It's basically the footbridge to the west of the existing Charles River Dam now.
And on the, will it be kind of muddy? Like, is it so sort of likely to be stagnant at some times of the year? Do you have a sense of that?
When the waters originally drop, there will be river mud on either side of that. That is actually a very high quality soil material, and it's a very competitive environment. They have a tendency to, basically, invasives can jump into that area and will grow very quickly. Based on past experience in other dam restorations and river restorations, they say basically within 2 years, the area is covered. The first year there will be exposed mud, the seeds will be cast, and that area will begin to grow up. A certain amount of control you would want to do to keep some of the invasives from becoming rampant in the area. But the area would be revegetated within about 2 years. And with about 5 years, we'd start getting woody and shrubby undergrowth in that same area, growing up to the point where you could see it and be growing higher than the grasses and the reeds that would be in that area. So yes, there would be some exposed area of mud that would be basically regrown within 1 or 2 growing seasons.
Thank you. Let's go following that, kind of where that took us. People are curious, who would own that land, and anything you can say about kind of property impacts at this point?
So that process, if a river changes its course, which they do, based on flooding and things like that, you get oxbows, that the river can change its course. If the river changes its course away from your property and gives you more property, that's actually called reliction, as opposed to accretion. Accretion is if the river dumps material on your property and moves away. That material is yours. Your land basically keeps extending out to the river. That does not actually apply when you change the course of a river by an act of man as opposed to an act of God. So looking through the deeds, the property along the southern expanse of the river is owned primarily by the town for the first few hundred feet around the area of the impoundment. Then there are 2 other owners between there and the footbridge. We would expect some of that area, the reliction, to actually affect the property. There are 16 properties between the dam and the footbridge on the northern side. Looking at their deeds declare them, that they are bounded by the river. Generally, what that means is when you're bounded by the river, you own to the center line of the river. If the center line of the river moves, you own to the center line of the river. So it's a very simplistic explanation at this point. And naturally, because I talked to a surveyor and then I talked to a lawyer, they talk me around in circles. However, that's generally the way that works. There may be special circumstances, there may be codicils, there may be clauses in people's deeds, running way back to the beginning when it was first inundated, when it was first allowed to be flowed over. There may be some other considerations in there. At this point, don't know. But as a general rule, as that as the center line of the river would move, your property lines would basically go out, and that property that is abutting your property that used to be inundated and is now no longer inundated, that is still your property.
I can imagine about 70 follow-up questions just to a few, as we answer one question.
I don't have a pat answer for that, and I won't. And that's something that will have to literally be looked into on a case-by-case basis, based on the language of the deed. This was done back in the 1720s. Many of those properties have been subdivided. There's been other owners, but you have to go back to that original flowage right when he originally flooded that area for the sawmill. What rights do those people retain?
Okay, thank you. There are many, many questions. I know we're not going to get to all of them. I want to ask you at least two more as we sort of move into our wrap up. One is, several people asked, could we put a structure in front of the earthen dam to somehow protect the trees and keep the spillway, or could we fill in the area behind the dam to make it stronger? Like, is there a sort of third option or alternative way?
Fundamentally, no. If I'm still calling that a dam, the earthen portion, the earthen dam, if I'm still calling it a dam, no trees. So if I have a wall in front of it, I've got a wall and a dam, still no trees on a dam. I got a wall and I've got material behind it on the downstream side, still a dam. So in that particular case, as a short answer, I would say no. The other idea is, what would that construction, entail to try and do that sort of work in a river to maintain the trees that are on that structure? It's like, what would that be worth? And I don't know. That would be what I would consider to be extraordinary construction. What we have just described has been, it's very commonplace. This is a very typical sort of operation to do around a dam. So this has been done before, very predictable, feel very good about the numbers that we have for construction and for the materials and the techniques for doing it, that we could find somebody around here who could do that work and do it well. That other work, no. We hadn't.
Yep, that's fine. Thank you. And then what is Natick doing in relation to adjacent towns? Someone asked if Natick has considered asking the adjacent towns to help defer some of the costs of repairing the dam, and just anything else you'd like to say about abutting communities.
So Bob, if Dover called you and asked you to help pay for a dam, what would you say? Probably not. It is our dam. It is completely our dam. We are absolutely consulting with the other towns regarding the ecological impacts of lowering the impoundment area, of allowing the water to flow free into Wellesley. We are dealing with them in their conservation commissions. We are dealing with them, their town engineers. We are consulting with them, but when it comes down to it, that's Natick's dam. And I know that they would probably say, we're not here to advise you one way or the other, because I think they would understand this sort of process that we're going through right now is, it's a Natick process. And we're doing this within ourselves to come up with what the town really wants to do at this point. It's really important to remember that regardless of what the decision is, the DPW will turn around, salute smartly, and will take care of it. If you want to maintain the dam, we will maintain the dam. If you want to take out the spillway, we will take out the spillway. We're not invested in either one of these, and we really, really are looking forward to the public impact or public feedback so that we understand what people would like to do. There are material reasons to get rid of the spillway. There are material reasons to keep it. So, this is a decision process. I don't think Wellesley or Dover or anybody would like to step in and tell us, what I'd do if I was you. I don't think they really have the appetite for that.
Thank you. I'm going to just, in front of everyone, consult Bill. It's approaching the end of the time we have allotted. We're going to come back together with everyone next week, anyone who can join us. Do you want to go a few minutes over? I don't know how we want. We can, I think there are many, many really excellent questions. I just want to name some of the most recent comments coming in are related to aesthetics and making sure that the advisory committee thinks about beauty and the place as they do their work. A lot of other ecological and recreational and cost questions, also some liability and insurance questions. We are going to take all of these questions and compile them and work with them as we develop information for the committee. Bill, Bob, your thoughts on kind of timing? Should we wrap and then come back and pick this up next week more? Should we go a little longer? What do you prefer?
I think it would be good to work, categorize all the questions and then be able to get more in-depth answers, especially about some of the legalities and environmental. So that I think they're great questions. I was looking at those, and I think also next week we'd want to have this would be a live interaction where people could state their preferences and for recreation or returning the river back to its natural state. So I think that might be the best way, because it's hard to give fair representation on the questions that are being put on there, and there's so many. There's close to 100. So I think we have some work to do, and I think we'll use that time to post the answers as best we can, and then get into it in a little more detail perhaps in the next session.
Thank you. So then I'm going to just go through some reminders and we'll wrap this up. This is the beginning. This is a lot, and some of you are going to dive deep into this, most notably the advisory committee members, but all of you are welcome to, go there with us, follow along this whole thing and keep giving your input. In the next few days, we will be posting this survey, which is really a set of open questions for you to tell us your thoughts on these different options, what you like, what questions you have, what concerns you have, and we hope you'll fill that out. It'll be the same. We will have this one survey open between now and about mid-June. So if you're going to come next week, you can give your comments then, or you can give them in the survey digitally. They all will be gathered and organized and treated the same way. It doesn't matter which way you do. We know not everybody has the time and the schedule to attend sort of live virtual events. So that's coming up. And then the advisory committee is going to take all of that input, and we're going to go topic by topic through all of these, on the financial pieces, on the ecological pieces. Somebody asked about the effect on Broadmoor, right? On all these different components that matter to people and that we want to think through before the community makes a recommendation. So they will be doing that work starting in the summer. And we're really looking forward to hearing all of your thoughts on these different options, knowing that information is imperfect, but hopefully you feel like you know a lot more than you did an hour and a half ago. It's been like such a pleasure to be able to share it with everybody all at the same time. Like, here's what we've got, and we'll keep answering questions as we are able as we go through this. Bob and Bill and Maggie, thank you. Thanks to all of you who spent your evening with us. Again, a reminder, you can go to the website and sign up for notifications. That's where you'll find the survey. And next week, Tuesday evening at 6 p.m. or Wednesday at noon, please come join and share your thoughts with us. We know this was really information from us out to you. We want to do the opposite next time around. So on behalf of the advisory committee and the staff who have been working on this, thank you all. Have a great night. Bye, everyone.